Good day everyone, and welcome to our presentation. This is our biggest audience so far, so thank you all for registering, and we've just been waiting for an extra few minutes for the additional attendees to kind of come along to give them a chance to settle in. So hope you're all keeping well, and sit back, relax, and settle into the presentation. Planning for this to run for about 30-45 minutes tops. I'm with my colleague Ludmila Vadeva, and Ludmila is helping me with the message board, etc. So do feel free to send in those questions as we go along. And the webinar today, the third one in this particular series, is on the subject of making space for water with microdrainage. And what we'd like to do today is to share with you the aspirations on what we need to achieve, and if we don't, the consequences. So looking at the agenda, why do we want to make space for the water in the first place? And why am I covering this particular subject? Well, it's due to your feedback from the last presentation. We asked you what were the key challenges, what are the pains that you're facing with regard to sustainable drainage systems? And number one on the list from your feedback was we don't have room. You know, we can't find the room and make space for putting in a range of devices that we potentially would like to put in there. So I've approached this topic first of all. The other two that came to the fore were the adoption and the maintenance, and we'll cover this in future webinars. And I'd like to throw out the idea to you all of us maybe inviting in guest presenters, and then we could have those address their requirements, whether they come from approving authorities or from developers or consultancies, etc. So I'll throw that idea out to you, and we'll give you the opportunity to feedback either through the message board to Ludi now, or if you'd like to do the Survey Monkey at the end, that would be really appreciated. So during this presentation, which is going to last about sort of 30-45 minutes, I'll run through some global experiences, both good and bad, and show how we can potentially work with nature. And the reason why I particularly warm to this topic is that every project is unique. So there is no one silver bullet. There's no one answer to fix all. It will depend upon your particular requirements on your particular project, wherever that may be. And I'm going to cover SuDS. Have I dropped the U on the fourth one down? Now we're looking at yet another acronym, so apologies for that. I'm not a fan of acronyms, but here's one to share with you on smart drainage systems. And after I've run through the introductory presentation to set the scene and share with you what's happening with legislation, we'll take a little bit of a look in the past and share that experience, look to the future and what's happening with legislation as it's coming through in different places of the world. And we do have a really good widespread audience here across the planet that are tuned in here today. And I'll run a live demo with the software. Now you may well all be familiar with the Venn diagram here, which is the traditional sustainable drainage systems Venn, looking at trying to address the balance between water quantity with water quality, as well as providing amenity. And that historically we have certainly failed in the developed world, but we're trying to address that with new developments moving forward and with rapidly developing countries across the world. When we start looking at smart drainage systems, what we're also looking to address is biodiversity. And I'm not saying this as some kind of a tree hugger. This is something that's coming through a governmental level or leadership level across the planet. And the biodiversity is coming through to the fore in a very strong way through legislation. And I'll share that legislation with you. So why do we need to put in the space for the water? Within developed countries, and I'm broadcasting this from the UK, and we've had a lot of historical infrastructure built over 100 years ago. It's reached its capacity on more than one occasion, and we're suffering from an increasing risk of flooding, and we can't afford that. This is the situation that we're in a highly developed country. Now, this is a list of concerns that are being raised by rapidly developing countries across the world, and I'm thinking in the Middle East. This is coming from a particular visionary document in the Middle East, and you can see the aspects that are raising concerns with a country that's going to develop in a very rapid way. What are the risks in the longer term? So it's fantastic that they can look back in history and learn from our errors of our ways almost, and then look forward to the future and address those right from the beginning of the process. So we have things like climate change, we have extreme weather events, there's water scarcity, hard to believe when you look at the photograph to the right. So I'd like to thank Simon Wilson over in Muscat for sending me this shot. This is flooding in Sur in the Oman back in June of 2007, where Muscat had a super cyclone go by. And you can see this is, these are wadis. This is normally a dry riverbed, but you can see the main river coming down here and then the tributary wadi coming in, but a stark contrast in color. So I think it really illustrates, A, the risk, the quantity of the water for sure. We do have flooding back upstream here and a lot of buildings and businesses affected here, but the quality of the water, this is soil mobilization. But imagine if this was maybe a car parking area or petrol filling stations, we're going to have a lot of pollutants flowing through within this water as well. So you can see the concerns, and I'm mentioning businesses because it's the cost to a country when business gets affected. It's a cost to businesses that will impact on the wealth and the well-being of everybody if that is affected. And after the global credit crisis, there's an increased focus upon money, a lack of money in some areas and what we spend it on in others. And talking of spending money, I need only go back a month, and this is headline news on the leading technical journal within the UK, the New Civil Engineer, and I know you get it overseas as well, but the headline news, splashing the cash, a year on from yet another flood, not just flooding event, but flood phenomenon. We're looking at where the money is being spent, the money now to mitigate. And we did a whole series on mitigation and modeling with Lumilla and Sama, you'll remember, using the XP Swim software. So we've got a real depth of experience in terms of existing flooding scenarios, and then we've got a depth of experience on trying to develop and design new, sustainable and smart drainage systems to avoid this in the future. And we're trying to do this so that we can actually, in the long term, save money, because at the consequences are stark. We can't afford to manage all the flooding and put in flood barriers across the UK. We've reached the point where we're having to now adapt and mitigate. So these visions, there are visionary documents for rapidly developing countries, and these are the concerns that they are raising. One thing I think we can all possibly agree on right now is that traditional drainage is limited. You will at some point reach the capacity of a traditional drainage system. So I'm kind of thinking pipes and manholes under the ground. So here's a fairly new expressway that's been built in a rapidly developing country, and within months of the expressway opening, it's underwater. And the water doesn't look particularly dirty here, but it's a depth and a velocity that's obviously affecting businesses across, and social impacts, people affected going around their normal lives or going to work, etc. Huge impacts. So we need to think beyond what we're designing. We need to think of the consequences of where the water will go after those capacities of those traditional drainage systems have been reached. They still have a role, they still have a part, but we need to understand and manage the surface water for the longer term benefit of everybody. And I want you just to step back and clear the mind of drainage and things, but let's just step back and think about it and put this into context now. So I call this the three pillars, and the three drivers are coming through from the highest of levels wherever you're listening to this from. We need to look at balancing, like the Venn diagram for the sustainable drainage idea, but to balance the economics along with the social aspects and the environmental aspects. And you'll start seeing things coming through on financial and built capital relating to economics, on social capital and natural capital. So we are influencing, if you're in the political system, we're influencing politicians. How do we talk to politicians? We have to put things in the context of money and capital. So everything has a value. And there's a massive amount of research that's been carried out, and that's being taken on board now by governments. And they are now really starting to drive through these new agendas, and it's a new way. So we're going to have to start thinking about designing with a new approach to satisfy these new requirements for the betterment, the long-term betterment of wherever you're living. By the way, when I put the presentation together, I've introduced hyperlinks into the presentation. So when you review this, and if we PDF the presentation for you, you can click on here. And don't take my word for this. You go and do your own research. You look at what's happening out there. Now, this is a particular event that's happening in about 3 weeks' time in the UK. And this is coming from the Public Policy Exchange people. And what they're running a meeting on, or a conference on, is the implementation or implementing the Natural Environment White Paper and the challenge that that now poses for the local authorities, the municipalities within the UK. So there's a white paper that's already been out. It's about 4 years old, that was produced by DEFRA, the Department for the Food and Rural Affairs. And now we're looking at the implementation of this white paper. This will come through as a bill, and it will be implemented through legislation. So what's within this bill, the Natural Environment White Paper? This is to do with the natural capital. And within it, the government is saying that it believes a healthy, well-functioning natural environment is the foundation of sustained economic growth, prospering communities, and personal well-being. So again, they're stepping back, looking at the 3 pillars, and then saying, how do we manage this? Well, the environment is at the absolute center of everything that we need to do in the future, because in certain parts of the developed world, we've decimated it, and now we're trying to recover it. So this white paper came out in June of 2011. I'm not sure if the guys in the UK are familiar with it, but as I say, you can link through and take a look. There are 92 commitments that the government is planning to aim for over the next 50 years. And when this came out, it really warmed me, because I used to believe that the political system was failing from the point of view that long term is 5 years. Each government is in for 5 years in the UK. But look at this. They've actually committed to the next 50 years. So this is a total inter-party commitment. And within that, you can see below, within the October 2014 implementation update that came out 3 months ago, that we've made some progress across the country. And what's happened is we've produced things like local nature partnerships. So everything has to drill down to the local level to actually implement. We've got nature improvement areas, huge reforms that have happened and will be happening with the planning system. So the adoption and maintenance, this will be addressed in April next year. How? Through the planning system. So you can see the main drivers are coming through on the new development side through the planning procedures. These are all government words, not anything that I'm putting together. This is coming out of their documents, that they're growing a green economy, putting our natural capital at the center of economic thinking. And they're trying to reconnect people with nature. And I was involved with a very interesting webinar about 3 weeks ago through the University of Stuttgart, and joint presented with Cecil van den Bosch from Sweden. And Cecil van den Bosch has got a lot of research on reconnecting people and nature. So forest cities is a paper that may be of interest for us to share with you for the future. But they're also looking at removing barriers, increasing the school's abilities to teach outdoors and create local green areas with green infrastructure partnerships, etc. So this is coming through the legislative process as we speak. How can we help? Why is that relevant to us? Well, during this particular series, the intention is that we just go through a systematic design process with you by taking into account natural flows that happen on site. What happens there now is what the environment will want to do in the future, no matter what we put in its place. And what we want to do is provide multiple benefits when we're building these projects and we're putting in smart, sustainable drainage systems. We want to provide multiple benefits for the 3 pillars into the future. These all have to be affordable, and I'm thinking the initial build cost has got to be, that everything has to be cost engineered down to the minimum cost, because we want to engage with the Home Builders Federation. I know that they're fearful of the costs of these things, making the space, etc. We're losing potential revenue sources, etc. But we need to have robust solutions, and those solutions must be not just maintainable, but at low cost, so that we can overcome the adoption and the maintenance issues, which were the other aspects that you raised as being real key blockers to making progress with this. So the images that I put at the bottom of the screen here, I want to thank Nadine Bittar, who's the founder of Placemaking, a company based in Dubai, but she's from a landscape architecture background and advising municipalities and ministries throughout the Middle East region, actually. And here's a particular project in Dubai that's been planned out and in the process of being designed and constructed. So they're actually implementing this vision in these kind of areas already. And on the right-hand side, I'm looking at a developed world scenario of what the consequences are when things go wrong. And this is showing you Overland Flood routing with XP Swim, the series that we ran before with Ludi and Samar. And this is showing you where the flooding is building up, running off across the ground. The red zone is the deeper section of water. A section of wall is collapsing, and then it's showing a shock wave of water going through and flooding a development, which is business, again being affected financially. So if we don't get it right first time, and in the developed world we're paying the consequences right now, we need to prepare for those consequences. And we're showing photographs at the bottom here of obviously major social impacts, environmental impacts, economic impacts of flooding in Riyadh here on the left-hand side and Jeddah on the right-hand side. Areas, in some cases, where there's been no rain for like 20 years, and now we're getting more frequent events and more extreme events. Whether that's climate change, this is a debate going on, but these are the issues. This is an underpass, absolutely full of water. A major highway going through a major city in a rapidly expanding country. So yesterday I received a post from Construction Week Online, and it just caught my eye, so I thought I'd share this with you, because Dubai has been named the most sustainable city within the GCC, and just below that, if you read the headline there, a senior statistician that's predicted that Dubai will become the center of the world by the year 2100. So it's going to take the title in terms of finance, etc. It'll take the title from London by the year 2100. So basically all of the expansion going on across Asia and Africa, the financial center is going to shift across from London and Europe and then go across to Dubai in the Middle East. So it's really interesting. What we need to do is to develop these places in a smart and sustainable way, and that's why I wanted to share the project here from Nadine Bittar. And I mentioned multiple benefits. Now, no one person is going to be able to generate this, so as we go through the process, those multiple benefits will mean that we need to work as a team, and we have multiple disciplines involved. And this is with the civil engineers coming from the municipalities, the consultants, developers, etc., but working very much more, I feel, hand in glove at the start of the process with the landscape architects. We're engaging more increasingly with sustainability managers, urban planners, to satisfy those regulators implementing the legislation that's cascading down from those visionary documents and the white papers, wherever you may be. And in amongst all of that context, don't forget the dear old software suppliers, i.e. XP Solutions. We're here to help. We've got the experience, whichever side of the coin you're working with, modeling and flood mitigation, or building smart and sustainable drainage systems. We're here to help you. So let me move on and show you the software live. I hope that helps with the context that I've sort of shown you now. And I'll open up the MicroDrainage software. If you haven't seen the software before, I've just opened up the software, clicked on the window and selected the module selector. And when I select the module selector, this little window will pop up. And you can see that we have a range of functionality within the software depending on the package, the bundle that you're working with. And today I'm really going to focus on utilizing the network option, which includes all of the functionality such as flood flow. So I'm going to bring in a land survey before we even started development, and then we're going to see where the water is likely to run across that land. Let's see where the water wants to run right now. I'll then bring in a layout, an architectural layout, and then we'll rerun the analysis and see what the impact of the architect's layout is having upon the overland flood routes. And then we can bring in the finished ground model and then see what we're doing in terms of mitigation or whether we could do a better job as we run through the process. If you have any questions about this, just drop them in the SurveyMonkey at the end. If you need any help with getting your head around which does what, we can help that, and the team are happy to contact and do this for you. So I'm starting off, basically think of this as being a open template. This is just a drawing board, and at the bottom left-hand corner of the screen, you can see that all the different functionality modules are taking their place. DrawNet is the graphical interface that I showed in the first webinar that embeds within full AutoCAD or Civil 3D. We can generate those flow conveyance networks within full AutoCAD and Civil 3D, but when you're looking at these modeling aspects, then I need to be working within the MicroDrainage package. They'll interface and communicate between one and the other, so it's not an issue. But let me just load in a three-dimensional land survey. So I'm going to load in a CAD, and if I click on load to import a CAD drawing, could be a 2D or a 3D. I'll go to my desktop, and this is the CPD3, Making Space for Water, where I've kept my files. So we have two options here. We can either bring in a DXF format, draw an exchange format, or we could bring in a DWG. So let me start off with step one. I'm going to bring in the initial land survey. So here's a site that is due to be developed. And what I'll do is I'll switch on with the columns to the right-hand side. Left-hand side is bringing in the imagery. Right-hand side bringing in the three-dimensional information, the Z coordinates, so ground points and Z coordinates when I tick the box on the right-hand side. I'm going to bring this in as proposed terrain, although I know it's existing land, but this will enable me to refresh with the latest information without any kind of confusion. We could bring in utilities, by the way. So here's another critical thing. What about if you've got a massive water main, a massive gas main, or something like that? You could bring in existing utility information, or if you know that you have a new utility that needs to be put across the site, you could bring that information in as well. This will enable us to avoid crossings and conflicts between major utilities when we're further down the line in the design process. But at the minute, I just want to take this information in. I'll say, okay, I'm reading in simple cover levels. So basically there are X, Y, Z coordinates for a series of ground points. So this is saying survey stations. It actually means ground points. So I'll say okay to that. And you'll see in the background, the image has been put on the drawing board for me. And if I run my mouse over the screen, we can see that we have at the bottom of the screen three sets of figures. There are eastings, the northings, and then the Z coordinates, the ground levels. So when I come off the model as I have, there is no level, 0 level. If I move kind of north, you'll see 159 at the bottom of the screen there. So the ground information has been brought in. So we can take a look at this. If I click on the view options to the left-hand side, just to orientate ourselves and see where's the highland, where's the lowland. It's a nicely contoured land survey, but is it sloping kind of southwest across to the northeast or northeast across to the southwest? If I click on the height map, this is just provided 7 bands of color in effect. And the way that I've set things up in the first place is to say, make the red the higher land level and make blue, the green and the blue, a lower level. So if I put the mouse to the bottom left-hand corner, we can see that the ground level is down at 138 meters above sea level. If I move over to the northeast, the land is rising up to 168, maybe 169 meters above sea level. So we've got about 30 meters of fall across this particular site. This is due to be developed. I'm going to turn the height map off, and what I'd like to do is identify that existing overland flood flow route. Where does the water want to flow? If we start to zoom in a little bit and take a look at the contours, we can see that typically from the top, it's likely to sort of sheet across from the northeast to the southwest. There's a little kind of gully in here, a little ravine in here, so there might be some changes in flow paths over the model. So far, I've been basically working with the DrawNet module with APT, and now I'm going to utilize the flood flow module, which is going to enable us to apply a depth of water across the land and then see where the water wants to flow at this minute in time. So I'm clicking on the icon at the bottom of the screen, the flood flow analysis. The program's going to split this particular model into grid squares, and those grid squares can vary from 1 meter by 1 meter to 50 meter by 50 meter and variations in between. I'll just choose the 4 by 4 at this minute in time, just to get a feel for where the water wants to run. And the surface is defaulting to urbanized, but it's actually rural. So this means it's applying a Manning's End roughness onto each grid square, the equivalent of grass. Okay. Now, I'm not applying a rainfall event onto the surface, but I'm applying a starting depth of water. And I could adjust this to whatever I'd like. 50 millimeters is a healthy depth of water. And let's see where that water wants to run over, say, a 60-minute period. And if I say OK, the program will now carry out that work in terms of splitting the model into grid squares 4 meters by 4 meters. It'll apply a constant depth of water of 50 millimeters across everything and see where it wants to flow over the 60-minute period. And at the end of the run, you'll see these squares have been colored in, and there are a range of colors ranging from blue up to actually yellow and white. If I right-click on my mouse, I can show you the display settings just to give you the key for the colors. These are the flood flow colors. And if I look at the spreadsheet at the bottom of the window, I'm saying to the program, don't show me any water shallower than 75 millimeters depth. It's not too significant. I want to focus on the deeper overland flood flow routes. I want to identify the blue-green corridor, the potential blue-green corridors running across this site that I can then utilize potentially as public open space to provide amenity, but also I could utilize this for overland flood routing as well. So again, I'm starting to think about what potential multiple benefits can we gain by just understanding the natural hydrology of the site. So from 75 millimeters to 150 millimeters, show me the water in blue, and then from 150 to 300 red, 300 to 600 yellow, deeper than 600 white. So the blue water is between 75 millimeters and 150 millimeters, and that's where it wants to run. So what I'd like everyone to do is really this at the beginning of the project, and then give the information to the architect or whoever the urban planner is to then scope out the site. But let's try to keep these corridors open, because sure as eggs are eggs, the water is going to want to do this. It's going to want to flow over this particular route unless we do some pretty radical things with the landscaping. So one of those initial meetings with the team, with the design team, share this information with the architect, bring in the landscape architect, and sit around the table and discuss. See what we can gain from this. You can see there's a deeper section up here. Even though this is the highland, you can see that there's a depression there. So that already could become like an attenuation area, like a wetland or a pond or something like that. Maybe. Just an idea. So what happens is typically the feedback that I have from all the consultants that I deal with is it doesn't kind of work this way. What really happens is that the land survey will go off to the architect and the urban planner. They'll then try to cram in as many properties as they can into the space available to maximize the value, because there's a different economic argument in terms of maximizing value out of land over a say 5-year period to develop this site, and then they have to make the drainage work. So this is what I'm going to share with you now is the layout that did come back to the engineers from the architects for their infrastructure layout. Before I do that, I can show you a couple of little tips and tricks when you have this information, because the architect may have some preliminary ideas. So if I click on the toolbox and go down to the miscellaneous tab, the toolbox is this little gray shed on the top toolbar, by the way. And what I can do is I can build glass blocks off of this digital terrain model, off of this surface. And these are known as flood flow exclusion zones, or flood flow exclude zone. So just imagine I'm going to build a glass wall or a glass block onto the terrain now. And maybe the architect, I don't know what this land is going to be used for right now, but maybe it's going to be a DIY center or something like that, and it's a great big building, or maybe a school or something. And this is the footprint of a building. So I'm just doing a kind of an L shape, obviously to try and capture that overland flood to make it a bad situation worse. If I right click, it's now produced a building on the DTM that's totally impermeable, and then I can run the flood flow analysis one more time using exactly the same figures and see what would happen to the overland flood routes if we put the building in that aspect, in that location on the land. So hopefully what I'm trying to do is to illustrate that this will give you some powerful arguments to help people better plan in the first place, right at the outset of a project, and it doesn't have to take a ridiculous amount of time to do this kind of work. Another tool that I could show you now is looking at this deeper water. I can move the mouse over each of those grid squares and take a look at the bottom of the screen, and you'll see the easting and the northing and the ground level, but now we have extra information such as depth and also velocity depth in meters squared per second. So where the mouse is right now, there's a depth of 764 millimeters. So we've had a starting point of 50 millimeters of water across the whole site. Within an hour, the maximum depth of water that has flowed across that particular grid square is 764 millimeters, which clearly, if there was an entranceway there, would have tried to flood the building. What's the maximum depth of water around here? You could go grid square by grid square, but we could drop a little target, a flood flow gauge. So let me click on flood flow gauge in the toolbox here, and then I'll click into the kind of middle of the water, left click, drag, and then I'm going to left click again. And if I zoom in a little bit for you, the maximum depth of water within that whole circle is 1.144 meters. The maximum depth of water within that circle of influence is 1.144 meters. Looking at the depth of water, I can strike a long section, a profile. So let me click in this ravine here, ravine, and then I'll go through the water like this. I could click, click, click and have a number of them, but I'll left click and then right click to then pop up a flood flow, sort of long section really. It says cross section, so flood flow cross section along that line. So 0 changes over here on the left hand side, and then we go up to about 200 meters length up to the right hand side. And what the program's done, it's picked off the ground levels, and this is a green line. So you can see the terrain levels are here, the green line, and then the top water level is the blue line. A little bit of a gap there, a little bit of a space, so the water is a little bit deeper down towards the bottom. But now you can see a clear space, and this is where we have our glass walled building. Basically here you can see where the water levels built up. This is all scaled off to the left hand side with levels above ordnance datum, and on the right hand side we have the velocity depth, and this is the purple line here. So this is referring to the right hand scale and telling us what the maximum velocity was across each of those grid squares along that cross-section line, and there is nothing faster than 0.022 meters squared per second. That's not an issue in terms of velocity, but we have an issue in terms of depth. If you want to look at the information in more detail, the program comes with a table. It'll extract a table. So the eastings and northings, the grain says cover level, it's really the grain level, water level, depth of water, velocity in meters per second, and then meters squared per second. All that information's there, which I can right click on and export to Excel, whatever. Okay. So you can see that there's a lot of things that we can do in fairly short order without any great effort using the tools available. I'm just going to delete these and then bring in the architect's layout. So if I get rid of what I've done so far in terms of the glass building, let's now import, by going back to the extent of the plan view, let me just import the infrastructure layout. So if I click on load and up to my desktop and pick another DWG rather than DXF, it's a DWG format of the architect's infrastructure layout. I can double click on this. We can see that it's a road design, a housing type layout with a pond to the southern end of the site. And if I scroll down here, I can pick up the layer off of the drawing that refers to the ground levels. So let me bring that in again as simple cover points and load in a refreshment. Say OK, and then it'll refresh what's there already. Now, because the levels have changed, the program realizes that the Overland Flood routing will therefore consequently have changed, which means I now need to have to rerun that overland analysis. And the only thing I want to change with the analysis is the fact that the surface is different. It's not all grass now. This is an urbanized surface. So we now have more of a kind of a tarmac, Manning's roughness, as opposed to the grassy roughness that we had before. And I can say, okay, I'll leave the same starting depth of water over the same period of time. I can hear Ludmilla tapping away there visually. So,
yeah, Peter, one question.
Yeah.
With flood flow, can users select their own Manning's values?
On the flood flow, to select your own Manning's values, they are set at this minute in time. But I would really welcome, again, with the Survey Monkey at the end, I had a word yesterday with our main researcher, Netsana, who's responsible for the MicroDrainage product range, and he's listed out all of the future enhancements that we could potentially put into the MicroDrainage package. We're coming out with the 2015 version before very long. Could well even introduce you to something in the next webinar. But at this minute in time, you can select rural or urbanized or mixed, and it will pick up a Manning's End for grass. It'll pick up a kind of Manning's End for a tarmac surface, or the average of the two at this minute in time. So yeah, it's a good idea. We can do that in XP Swim, so I can totally relate to what you're referring to there, and I think that would be a good enhancement, as well as potentially putting in the opportunity to have a variety of grid cell sizes. This is just analyzing the land because this is what the developer has bought. But if you're tuning in and you're an approving authority or a municipality, you're interested in more than this. You want to know, if I sort of zoom out, basically you want to have this development in the context of your catchment. So you want to know what's happening in the surrounding area here. Is this going to then discharge into what? Public sewer? Is it going to discharge into a river? Is there higher land up here where you have runoff coming down and potentially flooding across the site? And so we've had this so many times that we are now having to submit to the local authorities to put this flood risk assessment into context. So what I'm thinking is you could have a higher grid square definition of like 1 meter by 1 meter in here, but then you might want to go sort of 20 meter by 20 meter around the surrounding echelons, maybe. So yeah, at the minute it's fixed in terms of roughness, and we're fixed in terms of grid cell size. I'm just anticipating that question. But it would be nice to have more flexibility. And also, when I showed the height map, I'm also thinking it's basically taking the high point, the low point, splitting into 7 different layers, and maybe you want a different color for every 1 meter difference change in level or something like that. It's just another idea. So yeah, keep the ideas coming forward, folks, and the questions too. So we can now see there's a little bit of a change. The architect did do a massage on some of the levels. They put in some floor slab levels from the drawing, but they haven't actually detailed out the levels of the highway and the camber on the highway. That's the engineer's role. And this is typically what happens, is that they say, right, there's our solution. That's the sort of maximum value we can get out of this. And now make it work, please. Remember that the Overland Flood routes were trying to go northeast across to the southwest, and what they've done, they put in public open space up in the top left-hand corner. So the opportunity, the multiple benefits, open space, play area. Obviously don't want to drown people, but if it's tipping down with rain, I don't think they'll be out playing, but we could maybe potentially utilize some public open space and have that blue-green corridor as a connectivity corridor within the development itself, and put it at the heart of the development so people can walk around and take the dogs for a walk and bike ride, but also have storage areas upstream, in the middle, and throughout the development potentially. So that opportunity was missed. And what I'd like to do is the sort of third step, final step, is now bring in the model that the engineers, the infrastructure engineers, developed. Now you could be working with Civil 3D, you might be working with MX or some of these kind of products, or PDS. Let's go to the site drop-down and import that information, that ground model, which we consider, it's not a drawing, this is now going to bring in what we consider to be GIS data. So if I click on the GIS data, we can bring in landscape features, etc., and make things more realistic, but I'm focusing on the actual surface at this minute in time. And you can see all the information that's been preloaded in from the 3D CAD drawing as proposed ground levels. What I need to do now is basically refresh this and import the engineer's information. And it doesn't have to be this PDF, PWF format. I mentioned Civil 3D. You might be working with Civil 3D or MX, so you could export your highway model as an XML file. So here's an XML file that I've sort of generated. You could have a TXT file that's been generated, a CSV file that's been generated, or an ASCII, and that's really the LiDAR type information that you may have for the land survey in the first place. But the engineers actually generated this model using PDS. So I'll bring in the final infrastructure model that they generated themselves. Double click on say open. We have a warning that pops up to say, oh, you want to do you want to overwrite any existing terrain information, or the program will overwrite the existing terrain information if I say yes. Can't undo this. It's going to take out all those eastings and northings and levels and replace them with the latest. Do I want to continue? Yes, I do. I want to just use the latest information. That's brought the information into the program, and when I say OK, there'll be another note that will pop up which says the performance of the proposed surface may be improved by re-triangulating. Would I like to re-triangulate now? Now, because this is the latest up-to-date information, I'm going to say yes. If you've generated a triangulated model in Civil 3D and it has already been triangulated, you could load in the numbers like I've done, but then say no to the re-triangulation, and you're just going to bring in the net surface triangulated. So I'm going to say yes to this because this has not been triangulated previously. That's now refreshed my model. It doesn't look any different because I have the CAD drawing draped over that ground model. Now, to show you what that ground model looks like, I can click on the view options, and I could click on the tin, the triangulation that's taken place. And this is showing you a higher density of triangles underneath the highway. So this is where you have a camber on the road. And we also have another little tool that's useful here called the tin analysis. So if I click on tin analysis, immediately the program's looked at every single triangle and applied a vector arrow. So The color of the arrow will depend upon the slope of the triangle, and these red dots are meaning that there are sink points. So the triangles around this particular triangle are all higher than it, and it would be advisable to either get rid of the sink points in the ground model or put a gully in if it's a low spot in the curve there. If I turn that off and go back to the extents of the drawing, I can turn off the triangulation as well. How about we now deluge with the flood flow across that urbanized surface with exactly the same criteria as we used in the previous run. So now this is the more refined information. We haven't even started designing the drainage system right now. And we can start looking at predicting where the water is going to go, and now we can start the design process. We can step back, we can make decisions on what elements of sustainable drainage systems we could implement into the model, but we're now going to be limited because of the layout of the model. And it goes back to my previous point. I would like to do the deluging, provide that information to the architects, the urban planner, the landscape architect, and then let's get the maximum benefit out of this, because at the end of the day, we're going to have to test the finished design, and we're going to need to see where the water is going to go, and we're going to have to manage that surface water. And if we do this at an early enough stage, I believe that we can save some money for the developers in the first place. This is the key thing. Now, I'm zooming in because as the water kind of runs off site, it's this dear old plot 127 that's getting the brunt of the water. And all I'm working with here is surface data, CAD drawing, and deluging with water over the surface. I want to show you one Blue Peter model. Here's one I've done earlier. And this is after we've actually designed the drainage systems, the surface water and the foul water drainage systems. And I've gone beyond the design. I've added in for climate change, and now I've run dynamic flood flow analysis. And this is where the water wants to run across the surface when it floods out of the traditional drainage system, because predominantly this network is a traditional drainage system. Here's where the water is going to flood across the surface. It'll run and run and run. I've added in flood flow exclusion zones to the buildings. So these are kind of glass buildings coming off of the model, and I've just shown them graphically. And here's a property where the water is all flooding down towards. And which property is it? Well, it's going to be, if I right-click on the screen, dear old plot 127, even when we've designed the drainage system. So that's really concluding the end of this making space for water, because what I wanted to do is share with you the idea of starting to introduce smart drainage systems. And why do we need to introduce the smart drainage systems into our design philosophies is to satisfy those visionary documents, but also the legislation that's coming through, because whether you're a ruler or whether you're a political system, you have got to look out for the long-term benefits of your country. And this is now being driven through the agenda, which includes the natural environment increasingly at the scale. We need to balance the economics. So I'm not saying lose money for anybody. We need to do this and address the balance of the economics with the social impacts and the environmental impacts. And we can do this. We can do this already, and we've developed software over 30 plus years, and we're developing new software as we speak that we can share with you very shortly on providing these multiple benefits for the multiple disciplines that are involved in this process. And I'd really encourage you to help us at the end of the presentation. We'll send out a survey monkey. I've recorded the video and we'll put it up on the website when Stuart's kindly taken out my ahs and ums and polished up the presentation a little bit. We'll put it up on the website and send out a link so you can retrospectively go back and view it again. But if you could oblige us by going through the survey monkey, 5 questions, takes about 2 minutes to run through, because it will help us not just with the software, but also to put into the next webinar on the 11th of March to address the queries that you have. So it's the survey monkey that would really help us to help you. I hope that was of interest, folks. I really enjoyed your company once more. Thank you all for your questions. And Ludmila's nodding and waving, so it's a goodbye from Ludmila and a goodbye from me. And see you again on the 11th of March, if not before. Take care.